Bismillahirrahmanirrahim. Today we are going to start second session of our lecture week number 6 in operating systems course. Before to start second session, we will just take a quick overview of our first session in lecture week number 6. In uh, first session, we start our discussion from process scheduling, and we said that process scheduling is the key concept in computer multitasking, multiprocessing operating system, and in real operating system design. And what is process scheduling? This is the way processes are assigned to run on the available CPUs, because we have seen that in our system we have maybe more than one process. Many processes are available for execution, but we have limited number of processors. Okay, so we need some schedule to execute all these processes, so this is called process scheduling. Okay, we have scheduler or dispatcher that do this responsibility to make the schedule. Okay, and how they make schedule? By switching the CPU among process, the operating system can make the computer more productive. This is the objective, to make the computer system more productive. After that, we discuss about CPU burst time, and we said that burst time is the amount of time the process uses the processor. Okay, so how much time he need, any process need, that is called burst time. Okay, then we have seen the difference between IO bound process and CPU bound process, and we said the process that perform lot of IO operations and followed by a short CPU burst. Okay, so here we have two things, that computation and IO operation. If we have lot of IO operation and then followed by a very little or small or short computation, so this type of process are called IO bound process. And on the opposite side, the process that perform lot of computation and do little IO, that is called CPU bound process. Okay, then we discuss that scheduling criteria. Whenever we are going to select any algorithm, any scheduling algorithm, then we need to keep in mind these five things: CPU utilization, throughput, turnaround time, waiting time, and response time. Okay, so what is utilization? Because we want to keep the CPU as busy as possible. This is our objective, that we don't want that our processor become idle or in sleeping mode. Okay, so we want that make our CPU as busy as possible. So there is a range from 0% to 100%. Okay, so now the algorithm which will utilize our CPU more, that will be the best one. Then we have discussed throughput. Throughput is the number of processes that are completed per time unit. Okay, so here the algorithm which will execute more process in a unit time, that will be the best. Okay, so throughput, number of process that any processor is going to complete. Any algorithm is going to complete. Then we have seen the turnaround time. Turnaround time is the measure of time interval from time of submission of a process to the completion. Okay, so when we submitted the process and when he has completed his work, this is called the turnaround time. So we will calculate, and this time is the sum of the period he spent waiting to get into memory, waiting in ready queue, executing on CPU, and doing IO. Okay, so in all different state we will calculate the sum of the time. Okay, so this will be called turnaround time. Then we have waiting time. Waiting time is the sum of the periods spent waiting in the ready queue. How much time he spent in waiting, okay, in ready queue. So this will be the waiting time. And last one is the measure of the time from submission of a request until the first response produced. It is called response time. When you have submitted process and when he get the first response. So this measurement of this time is called response time. Okay, so we have these 5 criteria to keep in mind whenever we are going to select any scheduling algorithm. Okay, so for best scheduling algorithm, so which algorithm will be best, where that can maximize the utilization, CPU utilization and throughput. So what is utilization? That how much we are using the CPU from 0% to 100%. So the algorithm that will maximize the utilization, mean he will not allow the processor to be idle. So that algorithm will be the best one. And throughput, the how many process he can execute in a unit time, that is the throughput. So the algorithm which can maximize the throughput, that is the best algorithm. Okay, so also the in best algorithm, in choosing the best scheduling algorithm, we need to minimize turnaround time. Okay, that waiting time and response time. Okay, turnaround time is the measurement of the time from submission to completion. So the algorithm who is taking less time to complete one process, that will be the best one. Waiting time, the algorithm that have less waiting time, that will be the best one. And the algorithm that have less response time, that will be the best algorithm. Okay, so we finish our first session up to this slide. So now we are going to start second session in lecture week number 6. So now we will start our discussion on scheduling algorithms. Okay, in this course mainly we will focus on these 4 algorithms: first come first serve, shortest job first scheduling, priority scheduling and round robin scheduling. Okay, so we will start our discussion from our first algorithm, that is first come first serve scheduling algorithm. Okay, so this first come first serve scheduling algorithm is the simplest scheduling algorithm. Okay, as its name shows, first come first serve. The process that will come first, we will serve that process first. Okay, so this is very easy to understand. It is a very simple algorithm. With this scheme, the process that requests the CPU first is allocated the CPU first. Okay, so this is the technique, that the process that will ask for CPU, it will put the request for CPU. So we will give the CPU first. So this is the first thing, and it's very simple. It's very easy to understand. You will see, we will solve some examples. So we will see that this algorithm is the simplest algorithm from all these 4 algorithms. The implementation, if we are going to implement this algorithm, it's also very easy and easily managed with first in first out queue, because we already you already have some information, some introduction about queues in data structure course. So first in first out, the uh, process that will come first, it will out first. Okay, then the code for first come first serve scheduling algorithm is simple to write and understand. It's very simple to write the code for first come first serve. So we have some lab session where we will implement this algorithm, first come first serve scheduling algorithm. Okay, so these 4 points, they say that algorithm, if this first come first serve, the process that will come first, we will execute first. It's very easy to implement, very simple to write, understand. It's very easy, but we have some disadvantage also, and one of them is the average waiting time under first come first serve policy is quite long. So waiting time, because we have seen already the 5 criteria for best scheduling algorithm. For selecting scheduling algorithm, that is CPU utilization, turnaround time, waiting time, response time and throughput. So here one criteria, that is waiting time, but waiting time will be long. And if you see, so in choice of best scheduling algorithm, we have to minimize the waiting time. But here there is the problem of that waiting time under this policy is long. Okay, so this is one disadvantage of first come first serve algorithm. Okay, now we will see some examples. So first example that you can see here, we are considering that we have three process 1, process 2 and process 3, and all these processes arrive at time 0. They come at time 0. Okay, so arrival time is 0 with the length of CPU burst time CPU burst is given. Okay, so burst time for P1 burst time is 24, for P2 burst time is 3, for P3 burst time is also 3. Okay, so what is burst time? That the time, amount of time a process need the CPU. Okay, so now we have to see the order. The order is the process arrive in the order P1, P2, P3 and are served in the first come first serve order. We get the result shown in the following Gantt chart. So first thing we need to make the Gantt chart. Okay, according to the information that is given in this table. Okay, so which process came first? That is P1. So we will execute this process first. Then we will execute second process P2, then process P3. So what we will do, we will make a Gantt chart like this, that okay, so this is our Gantt chart. Okay, always we will start our execution of process from time 0. This is time. So here time will increase from left to right. Okay, so this is showing that time is increasing from left to right. So which process we will execute first, because this is first come first serve. So here we will execute the first process, that is P1. Okay, so how much time he need 24 milliseconds. So we will from 0 to, we say that is up to, like suppose here this is 24. So execution of this process is finished. Now we can mark here it is done. The first process P1 has finished his work. Now the second process, that in order we have process P2. So we will start execution of P2 from time 24. So P2 it will be here, and how much time he need, this is execution we are going to execute, and how much time he need, 3 milliseconds. So it means from 24 we will add 3, 25, 26, 27. So it means this process will we finish his work at this time 27. Okay, now the execution of this process is also finished. Mark it that it is complete. Then we will start execution of our process P3, because this is on number 3 in the order. Okay, so we will start execution of process P3 from time 27. Okay, now how much time he need? He need 3 milliseconds. So 27 plus 3, so it means at 30 it will be finished. Okay, so this is the first thing. Whenever there will be any question that to execute the process, this is first thing that you need to make Gantt chart. And whenever you have Gantt chart, this is correct, then you can easily calculate the waiting time for each process P1, P2, P3, turnaround time for each process, and response time for each process. So we will see some, this is very simple example, and you have seen that's very easy to understand that which process we need to execute first. That is in the order we have P1 first, P2 second, P3 third. So here also remember that arrival time is 0. Arrival time is same for all the process. Okay, but the order is different. Here P1 first, P2 and then P3. So here you can see that this is P1 we started first at time 0, then up to 24, then from 24 to 27 this is process P2, and from 27 to 30 we have process P3. Okay, it's very simple that how it is. Now this is our Gantt chart that we make in the last slide. Now what is our next task? To calculate the waiting time for P1, P2 and P3. So how we will calculate the waiting time? It's also very simple that we have to understand the formula. What is formula to calculate the waiting time? So here I am going to write okay, just I'm going to write here formula to calculate the waiting time. So formula for waiting time will be waiting time is equal to execution start time minus arrival time. So this is the formula that you need to understand, that formula to calculate the waiting time. So what is waiting time is equal to execution start time minus arrival time. So this formula we are going to use to calculate the waiting time for each process. Okay, so now what will be the waiting time for process P1? Here, if you see this uh, this Gantt chart, the waiting execution start time for process P1, if you see here, this is P1, and when execution start for P1, this is 0. It means at time 0, the execution of P1 is started. So execution start time is 0 minus, according to this formula, execution start time minus arrival time. So what is arrival time? And if you see in last slide, it is given that arrival time at 0. All the three process that arrives at time 0. So arrival time is also 0. So it means what will be 0 minus 0? It will be 0. So waiting time for process P1, it is 0. Okay, now the waiting time for process P2. So when, if you see this chart, when the P2 start execution, that is 24. Okay, so P2 start execution from time 24. So we will write here execution start time 24 minus what is arrival time. Arrival time, it is given in last slide, that is 0 for all these three processes. So it will be 24. So waiting time for process P2, it is 24. Then we have third process, that is P3. So what is execution start time for process P3? It is 27 minus what is arrival time? It is 0. So it is 27. So now we have calculated here the waiting time for process P1, it is 0, for P2 24, for P3 27. Now we need to calculate the average. So we will add these three, 0 plus 27 plus 24 divided by 3. So it will give us the average waiting time for P1, P2 and P3. So we have seen here it is 17 milliseconds. Okay, so this is very simple how we can calculate the waiting time for any process. So the important thing is that you must understand the formula. Okay, so what is waiting time? Waiting time is execution start time minus arrival time. So this waiting time is whenever you have only one instance of each process in the Gantt chart. Here see, P1 is only one time, P2 is only one time, P3 is only one time. So whenever we have more than one instance, then I will explain how you can calculate waiting time for each instance. But for one instance, this is the formula, that waiting time is equal to execution start time minus arrival time. Okay, so now this is example 2. In this example, if you see that we have same process P1, P2, 3, P1, P2 and P3, but just I change the order. After changing the order, now P2 is first, so we will execute P2 first. It is 3 milliseconds, and P3 3 milliseconds, and P1 3 milliseconds. Now we will compare the waiting time. It will affect waiting time or not. Okay, so what we will do? We will start making Gantt chart. Okay, so we will always start from 0. So which process we will start now in this case? That is P2. P2 we will start. So how much time? It will be for 3 milliseconds, and now this process is complete. Now second we will start process P3. So P3 also is burst time is 3 milliseconds. So for 3 milliseconds we will execute. It will finish at time 6. Okay, now we will start our third process, that is P1. So P1 start execution at time 6, and when he will complete at 30, because his requirement is 24 milliseconds. So this is Gantt chart. It's very simple. Just first the process that is first in the order you need to execute first. Now we are going to calculate the waiting time. So this is the Gantt chart that we have constructed. So again, what is formula to calculate the waiting time? Formula that is same, that execution start time minus arrival time. So for P1, if you see, for what is waiting time for P1, what is execution start time for P1, that is 6, minus what is arrival time? Arrival time, it was given in the question, that is 0 for all these three processes. So what is waiting time for P1, that is 6 milliseconds. Then same for P2. See the chart. When P2 start execution, see here, that is 0. Execution start time is 0, minus what is arrival time? This is also 0. So it is 0 minus 0. So what is waiting time for process P3? So here if you check P3, that is 3 execution start time minus arrival time. So this is 0. So it means 3. Now what will be the average? That 6 plus 0 plus 3 divided by 3. So it will be, sorry, it's wrong, it will be 3 milliseconds. Understand? So if we change the order, if you go back and check the last slide, in last slide we have calculated the average waiting time is 17 millisecond, but here we have seen the average waiting time is 3 millisecond if we change the order. One thing that you need to remember, that first come first serve scheduling algorithm is non-preemptive. Okay, here this is non-preemptive approach. So we have seen that in our initial lectures we have two type of multitasking, preemptive and cooperative. Cooperative and preemptive. Preemptive is that we can take the control of our processor back by force from any process, but in non-preemptive it is not possible. That once the CPU has been allocated to process, whenever the CPU we have allocated, we have given to any process, that process keep the CPU until it release the CPU, either by terminating or by requesting IO. Voluntarily if he is releasing, he need some other resources like IO devices, or he finish his work and he is terminated, he exit from the system. This is, otherwise we are not able to take the control back by force. So what we learn in this first come first serve algorithm, that the it's possible that waiting time will be quite long as compared with the other algorithm. So we will see some other algorithm, then we can make a comparison between these algorithms. And also we are not able to take control back by force because this is non-preemptive. Okay, so first come first serve scheduling algorithm, it is non-preemptive. We are not able to take the control back by force. Okay, now this is our uh, first come first serve algorithm. So I also have some tutorial related to the first come first serve algorithm when the arrival time is given. Let me check that, maybe I have here. Yes, here if you see this tutorial, that we have four process, and P1, P2, P3 and P4, and arrival time is different in this case. Okay, 0, 2 for P3, 3, and for P4 it is 5. And bus time is also given. Now you need to make a Gantt chart for first come first serve scheduling algorithm. So of course, uh, whenever you will make the Gantt chart, and after this to calculate the average waiting time for part A, it will be different because you have the formula for P1 execution start time minus arrival time. So it will affect when in our first example that we solve, that execution start time, sorry, the arrival time for all process it was 0, same, but here in this case if you see that arrival time is different. For P1 it is 0, for P2 it is 2, for P3 it is 3, and P4 it is 5. So I have also, so let me check that. Okay, so what is your task that you need to solve this tutorial? Okay, so you will also find the solution on Blackboard, but try to solve by yourself. So this is our first algorithm, that is first come first serve scheduling algorithm. It's very simple. Okay, so in same way you can calculate the average turnaround time, you can calculate the average response time. So in shortest job first I will tell you that how to calculate the turnaround time and how you can calculate the response time. Okay, so we will stop here our second session, and just we will take a quick overview of our first algorithm, that is first come first serve algorithm. And we have seen that is this is the simplest scheduling algorithm. Okay, the with this scheme the process that requests the CPU first is allocated the CPU first. Implementation is also very simple, but on the negative side the waiting time under this policy is often quite long. Okay, so this is the one drawback, one disadvantage of first come first serve algorithm. And then we discuss one example where we have three process and bus time is given, but arrival time for each process it was 0. Okay, so how the what is the first task for you to make the Gantt chart from the table above, from the given information to make the Gantt chart. Whenever Gantt chart is ready, then next is to calculate the waiting time. Okay, so how to calculate waiting time? Waiting time is equal to execution start time minus arrival time. Okay, then we have seen if we change the order also it will affect the waiting time. In first, whenever the order was P1 first, P2 second, P3 third, then we have seen the average waiting time was 17 millisecond. but whenever we have changed the order P2, P3 and P1, we executed P2 first, then P3, then P1, then waiting time is changed. Either the and you have seen the bus time for each process is same. We did not change this, but just we change the order. Also, what we have seen here that this algorithm is non-preemptive. Okay, we are not able to take the control back by force. Okay, so this is preemptive, non-preemptive approach. So some algorithm, next algorithm that we will start even in our third session, we will see that this algorithm is preemptive approach, that shortest job first scheduling algorithm. So if you have any question, you can send me email or you can visit my office during my office hours. So see you in third session of lecture week number 6 in operating system course.